Okay, hi grade 10. So this is the video for 3.3 or Unit 3, Lesson 3. So for this lesson, you're going to learn about perfect squares and perfect cubes. So from grade 9, you may remember that a perfect square is, for example, 25. And the reason 25 is a perfect square is because to multiply for 25, I can multiply something by itself. So 5 times 5, okay? So 25 is the perfect square. And the 5 is the square root. Okay, another example could be if we were in class, I would ask someone to give me another example, and I would say maybe 100. Now, there's lots of ways to multiply for 100. 25 times 4, 2 times 50. But the reason that 100 is a perfect square is because you can write it as something times itself, 10 times 10. So again, in this case, that 100 is the perfect square and the 10 is the square root. Now, a perfect cube is, for example, 8. And the reason 8 is a perfect cube is because we can think of something that times itself 3 times. So cube means 3. Square means 2 times. So what times itself 3 times gives us 8? Well, it's 2 times 2 times 2. Okay, so 8 is the perfect cube. And the 2 is, oh shoot, not square root. The 2 is the cube root. So the cube root of 8 is 2. Another example of a perfect cube would be, let's see, 343. Okay. And the reason 343 is a perfect cube is because 7 times itself 3 times gives us 343. So again, in this case, 343 is the perfect cube and 7 is the root, the cube root. So the next question here, what we're going to get into today is determining the square root of a number, a big number, 1296, using its prime factors, or in other words, we're going to use the factor tree that we've been practicing the last couple of days to find the square root of 1296. So the way we find the square root of 1296, that was really ugly. Let me just do that again. 1296 is we start like any other factor tree and think of a way to multiply for 1296. So if I take my calculator and go 1296 maybe divided by 4, it works out. I get 324 and 4, and I know I can break down that 4 to 2 and 2 and circle them. 324 I'll divide by 4 again, and it works, and I get 81 and 4, and that 4 I'll split into 2 and 2 and circle them. Now 81, I'm going to go 9 and 9. I can't circle those yet because 9 and 9 can break down again to 3 and 3. I do the same thing for that one, 3 and 3. Okay, so there's all the prime factors for 1296. So I'm asking you, what is the square root of 1296? So what number times itself gives me 1296? And so what we do is we take our prime factors and we create, oh my gosh, what did I just even spell? Create 2 identical groups. So you take all of your prime factors. So I have 2, 2, 2, 2, 3, 3, 3, 3. So if I want to create 2 identical groups, since I have 4 2s, each group gets 2. And then because I have 4 3s, each group gets 2. So I have taken all of my prime factors, 2, 2, 2, 2, 3, 3, 3, 3, and I've split them up into 2 identical groups. So now I can actually solve this. You say, well, what is 2 times 2 times 3 times 3? And that's 36. So really, I got here 36 times 36 equals 1296. So the final answer here, the question was asking, what's the square root of 1296? And we found the answer to be 36. Okay, simple as that. So let's create two identical groups. All right, let's do another one. This time 1764. So we're going to take 1764. I'm going to try dividing it by 8. Oh, I got a decimal. That doesn't work. 1764 divided by 12. I get 12. That was ugly. I get 12 and 147. Why is it doing that? 47. Then for my 12, I'm going to split that up to 4 times 3. And then the 4 to 2 and 2. Circle, circle, circle. 147, I just know that that divides by 3. So I'll go 49 times 3. I'm going to circle that 3. 49 breaks down to the only option is 7 times 7. Okay, so again, I'm going to create two identical groups. And when I multiply them, they have to equal to 1764, excuse me. So if you look at all of your factors, you have 2 2s, 2 3s, and 2 7s. So create two identical groups. So because I have 2 2s, each one gets a 2. Because I have 2 3s, each one gets a 3. And because I have 2 7s, each one gets a 7. So let's verify. 2 times 3 times 7 is 42. So I'm really saying that 42 times 42 equals 1764. And just double check your work. 42 times 42 does in fact equal 1764. So we know that the square root of 1764 is 42. And there's your final answer. Okay, so now we get into something a little bit different. Sorry, I know I scrolled away pretty quick. You can always rewind if you want. The next question is to determine the cube root of 1728. So notice here that we're actually changing. Now I'm asking for the cube root of 1728. And we know that cube root means something times itself 3 times. So we're going to do the exact same thing. We're going to create a factor tree for 1728, just like we normally do. But we're going to create 3 identical groups in the end. So I'm going to go 4 times 4, 32. I don't know why my pen's doing this. Sorry, you guys. Like I said in class, I'm still trying to figure this out. 4 times 4, 32. Okay, and then 2 and 2 for the 4. And then 432, I can divide that by 4 again. So I'm going to go 4 and 108. The 4 breaks down to 2 and 2. So we just have the 108 left. I'm going to go 2 and 54. So I can circle that 2. This is a long one. And then 54, I'm going to go by 9. 9 by 6. The 9 becomes 3 by 3. The 6 becomes 3 by 2. I circle all those prime factors and we have a bunch. We have 2, 2, 2, 2, 2, 2, and 3, 3, 3. So now, because it's cube root, we have to think of something times itself again. So 3 groups. So you look at your factors and you split them up 3 ways. So if you look at your 2s, you have 1, 2, 3, 4, 5, 6 2s. So if you want to split them up evenly between your group, each one gets 2. So you can write 2 squared or you can write 2 times 2. Same thing, doesn't matter. So I'm done with the 2s. Next is the 3s. I have 3 3s. So that's easy. 1 to each. Oh. So 2 times 2 times 3, you guys, is 12. So I'm essentially saying that 12 times 12 times 12. Sorry, I'm going to try to move something here. No, that didn't work. 12 times 12 times 12, oh well, you get the gist, should equal 1728. So you can just double check that on your calculator, and it does. So we are saying then that the cube root, so you have to put that little 3 there now, the cube root of 1728 is 12. Okay. I'm going to actually skip this question for now. I think you guys get the gist. It's exactly the same thing as doing square root, but you just make 3 groups instead of 2. So I'm going to skip this next example, but I am going to do this last one here. It's a little bit different. So it says, determine if the following numbers are perfect squares or perfect cubes, or maybe they're both, or maybe they're neither. So the way we do this is we do the factor tree for 729 and we just kind of see what we're left with. So 729, I'm going to divide by 3 and I get 3 times 243. I circle that 3. 243, I'm going to divide by 9 and I get 9 and 27. Whoops, 27. 9 goes 3 by 3, circle, circle. Sorry, 3 by 3. 27 goes 9 by 3. And then 9 goes 3 by 3, circle, circle. Okay, so I have all 3s. I have 3, 3, 3, 3, 3, 3. So we have to figure out, is it possible to create 2 identical groups? If so, it's a perfect square. Is it possible to create 3 identical groups? If so, it's a perfect cube. Okay, if I can't do anything, well then it's neither. So if I start with perfect square, I have 1, 2, 3, 4, 5, 6 3s. So I could go 3 by 3 by 3 times 3 by 3 by 3. So yes, I can create 2 identical groups. And so that means that 3 times 3 is 27. That yes, it is a perfect square and the square root is 27. Now, can I create 3 identical groups? So again, I have 6 3s. So I could go 3 by 3, 3 by 3, and 3 by 3. So yes, I can create 3 identical groups. So that means that the cube root is 9. So the answer to this question is that it's both. It is both a square root and both a square root and cube root. Okay. Next question, we do the same thing. So 2056. Let's divide that by 4, and I get 4 and 514. And then 4 splits to 2 by 2. 514, I can do that by 2 again, and I get 2 and 257. Sorry, that was ugly. Looked like 287. 57, circle. 257 divided by, what works? 3 doesn't work. 7 doesn't work. 9 doesn't work. 11 doesn't work. 13 doesn't work. So it looks like nothing really divides into 257. So if we were in class, I would say, is that a prime number then? And unfortunately, my poster doesn't go up to 257. So I'll just let you know that yes, 257 is prime. Okay, so we tried a whole bunch of numbers, they don't work. 257 is prime, believe it or not, nothing divides into that, so we stop. So now if you ask yourself, can you create 2 identical groups? Well, no, of course not, because you only have 3 2s, so you couldn't split them up evenly. And you have a 257 that obviously you can't split up evenly. Same thing with creating 3 identical groups, same principle. There's no way we can divide this stuff up into 3 nice, simple, identical groups. So this number 2056 is neither a perfect square or a perfect cube because we can't make identical groups. Okay, so if you scroll down here, you'll see the assignment listed. It's a textbook assignment, page 146, 456, page 149, number 8. So you can grab your textbook, you can grab a page of loose leaf, you can start copying the questions and put that in your duotang. Okay? See you later.